Hello, welcome to Happy Maths Hour. It would seem that I've done it again. I didn't send Toni the link this time, as opposed to sending her the wrong link. So I will, must have sent it to the wrong person. Okay, so Toni will be with us in just a moment. And what we will be talking about today is we're going to be talking about spot the mistake, how to learn your maths, learning class, by spotting the mistake that perhaps somebody else has made. Well, no, that somebody else has made. That is the key to everything that we're doing today. It's a great learning technique, and we will we'll be talking about introducing the spot the mistake straight after our lovely jingle, which is coming up just now. Hello, Toni. So instead of sending you the wrong link this week, it seems like I sent your link to somebody else. Don't know who yet, but anyway, you're here. So today is welcome everybody to Happy Maths Hour. And today it's all about spot the mistake, and the wonderful exercise that Toni is introducing is based around the concept where, if let's say that you're a teacher or a parent and you're given something that's wrong, where there has been a mistake, the teacher could then take a copy of it and share it with the whole class, or there'll be more than one mistake, so share all the mistakes with the whole class, and everybody's got to spot the mistake, figure out what went wrong and how to fix it. And the amount of learning that goes into that is tremendous. So right, Toni, welcome. Well, we're co-hosts. Lovely to see you, Toni. And I've just had the most amazing session with Christiana. I think I'm going to share it with you later, and I think you're going
to. Caroline, hello. Good to be here, and I'm going to share my screen. Now, that isn't the right one, so I'm going to cancel it and start again, and then everybody will be able to see what we are looking at.
So
ridiculous, because I do have the right thing on the screen and I should be able to share it.
Toni and I work on
well, you didn't get me in time, Caroline. I would have done this before. Okay.
I can't any sooner, Toni, because it's because I finish it literally. I finish one and start another. But what I was going to say is Toni and I work with the growth mindset, which means that whatever is happening, we can find a solution and overcome it. And it's Toni's the most amazing person, that she gets excited about learning something new. I was teaching her how to use iMovie. She goes, "Oh, this is exciting. This is difficult. I'm so excited."
So Caroline, can you see my screen?
Yeah, added it to the stream, and here we go. Here comes Spot the Mistake. Sounds like a thingy show, one of those television shows, a quiz show.
Can you see the screen, Caroline?
Oh yes, it's beautiful.
Excellent. Excellent, excellent. Now, it's a useful teaching strategy. It could be a mistake made by one of the students in the class, or it could be something that you've prepared like this, which is a puzzle. And the idea is that the students can find how these methods work, and they can spot mistakes and put them right. Now, this first one shows 2 digits 79 being multiplied by 8. and 3 digits, 239, being multiplied by 7, but it shows this multiplication in different ways, and it shows division as well. So there's a lot in there. And it can be used for what's called diagnostic assessment. What's that? Well, if you go to your doctor and something's wrong, you tell your doctor about what's bothering you, and the doctor diagnoses what's wrong and possibly gives you some tablets or something or whatever. Now, a teacher does that in the classroom. A teacher tries to understand why students are puzzled and can't start the work, can't get on with it, and they use diagnostic assessment. And this is a really good way of doing diagnostic assessment, because the learners have to investigate for themselves. And if they do this in pairs, it's a really good idea, so they can talk about it. And by comparing the different methods and working out for themselves what's going on, some of those answers are right and some are wrong. It really helps the learners to sort things out. And if the teachers are then using this, they can usually see what the learners are finding impossibly difficult.
Okay, and the Toni writes a home learning guide for all these activities that we're doing on Happy Maths Hour. And so I'm going to talk to the parents now. Now, I know that some of you will see these methods and go, that's not what I did in school. I didn't do it that way. And so a great activity is for you to actually, and this is part of the activity for the young learner as well, is to work out, look at each of those 4 examples and work out how it works. They're all different methods of doing the same thing. And if you work out how they work, that will actually increase your ability and the ability of the learner, if you can do all 4 methods, it gives you a lot more number sense, and it gives you a lot more fluency in playing with numbers, and it'll help your learner with their homework.
Absolutely. Yes. I mean, there isn't just one way of doing a calculation, and it's a big, big mistake to force the learners to do it in a particular way, because they may find it's easier to do it in a different way. Now, this is the second puzzle. And, well, you might have odd socks, but every time you put on your socks and shoes, you do it in the same way. You put on your socks first and then your shoes. And when you reverse that and you get back to being barefoot, you take your shoes off first and then socks off. So putting your socks and shoes on and taking them off are inverse operations. One undoes the other. And this puzzle shows how multiplication and division are inverse operations. Well, if you multiply 239 by 7, you get 1,673. And if you divide 1,673 by 7, and you do it correctly, you get the answer, 39. So these 3 numbers, 239, 7, and 1,673, are linked together both by multiplication and division. And you can see that multiplication produces an answer, 1,673, and then the dividing undoes that and gets back to this 239 from which you started. One other thing I was going to say is you can use this as a game in the classroom or at home. And it's a game where you show one of these puzzles for the first time, and everybody who's playing the game, it's a good idea to play it in pairs, actually, so that two people can work together and help each other. Everybody who's playing the game works really hard to discover how the methods work and to find the mistake and put it right. And then the first person who can do this and go to the board and or write it down and explain it for everybody else gets a point. So it's a game to be the first person to be able to explain it. And if you can't explain it all, then the other players have a chance to explain it. It can be turned into a game, or it's just a puzzle, if you like. Now, shall we have a jingle, a break? And
is it time for a break? And is it time for a break? Is that where we are? Sorry, I'm just sharing. I'm on doing my social media thing, Tony. So we're going to do the jingle. We've got it all scheduled this time. So after the break, we'll look at some neat ways of doing calculations, back to what we were talking about to help the parents work things out. And I'll go back to doing my social media sharing. Oh, we haven't done a jingle at all yet, Tony. Or have we? Oh, I don't know if we have or haven't. There we go. See you after the break with neat ways of doing calculations. Stay tuned. Welcome back.
Caroline, it's your turn to talk about this one.
My turn to talk about this one. So we're looking at different methods, and this is something where these aren't the only methods you can use. People use these methods doing mental arithmetic, and it is absolutely essential to understand place value. In other words, understand which are the units, which are the tens, which are the hundreds. And if you don't already understand it by doing these activities, it can really make it clear. You learn it. You learn by doing, literally. You think, oh, well, that doesn't work right. So what did I do wrong? Where should that number be? How much is that number worth? And so we've got the different ways. We've got the standard way, 51 times 29. Wait a minute. No, that's not the standard way. What have we got here? Oh, I don't know that first one. I'll come back to that. I'm going to start with, actually, the one that I really resonated with. On the bottom right-hand corner, you've got 29 times 51. So what we've done is 29 times 50, which is a much easier thing to do, and then add the 29. So you have to know that the 29 times 51 is basically adding 29 together to each other, essentially 51 times, or 29 groups, or 51 groups of 29. And therefore you can absolutely validly say 29 times 50 plus 59 plus 29. 29 times 50, and then add the 29, and that gives you 29 times 51. And all of these are based on having that fluency, having that agility with playing with the numbers. Again, you've got the other one of going upwards, going from 29 to 30, and then taking away 51. So you can go with what you feel most comfortable with.
Caroline, you need to spot the mistake.
Have I got to spot the mistake? Right.
Well, no, listen. Look at it again. The 29 times 51, which I just so rightly said was 29 times 50 plus 29. The next line is a mistake.
Oh, I hadn't looked at the next line. Oh, my goodness. So we've got 29 times 51 is... Okay, so it's
no. The third line, the 1,450 times 29, plus
Oh, it's
29 is correct.
1,140. Oh, that's correct. Okay, so that calculation. So you've done.
So 29
I
times.
haven't looked at that third line. So
Well, what it is, Caroline,
there,
is that there's a decimal point missing.
yeah, because you've done 2 times 50. A decimal point or a
decimal point, Caroline. You see, if you multiply 50 by 2, you get 100. But then that will multiply everything by 2. So you've got to divide by 2 at the same time. And if you divide 29 by 2, you get 14.5.
Okay, hold on. Wait a minute. No, I hadn't looked at that third line there. I hadn't actually gone into this in minute detail. So you've multiplied. I see what you've done. Now I got it. You've multiplied the 50 by 2, therefore you have to divide the 29 by 2.
You have to halve the 29 to get
halve the 20. You're doubling the 50, halving the 29, so that you'll then do. Oh, how beautiful. That is not a process I've ever used. So you're if you see you've got a 50, you're doubling the 50 and halving the other number so that you can then multiply the other number by 100. But Toni has inserted a typical mistake, which is not making 29 divided by 2 145 instead of 14.5. Nice one, Toni. And the beauty of this is that you're attempting to make the problem easier by doing some jiggery pokery, but you've got to make sure that you've got the answer correct. Now the thing is, the next line is correct, so you would actually, if you're doing exams and tests, you would actually lose a point for that middle line. But on the other hand, you would keep you'd get your end result correct, because this is one of my huge bugbears, is always write out your calculations, whether you're doing a test, whether you're doing anything, just so that you can review what you've done, that you can find out where you went wrong, and you can spot your own build, because we all have our own little things that we tend to do. And the only way to overcome the little mistakes each of us tend to do, is by knowing what you're doing and practice it and be aware of it, so that you don't keep making the same mistake.
But you see, Caroline, there's 2 mistakes and they cancel each other out. So you get the right answer at the end. The second mistake is that 145 times 100, right, is 14,500. So if you don't put the decimal point in the line above, then the next line doesn't follow. Okay.
We're going to talk about that in a minute, aren't we? Because what that person's done clearly, which is you knew what the answer kind of was at the end. You knew it was going to be around, because that's the first thing. This is the first thing I do. I learned that the hard way. I really did learn that by making lots of mistakes. And that is, if I see 29 times 51, the very first thing I do is say, okay, approximately where will that answer be? So I just forget the 9 and the 1, and I just go, okay, what's the closest, the nearest number to 100? So I'm going to round to the nearest 100 for the answer. I'm going to round to the nearest 10 for this, to the nearest 5 or 10. So for this one, I'd go 30 times 50. Okay, it's going to be around 1,500. So if I found my answer, which I'm perfectly capable of doing, was 14,000 and something, I'd go, okay, I know it's wrong, because it's nowhere near 1,500, or nowhere near 1,500. So then I would then go back and see where I'd made my mistake.
So this is really good for estimating. Now, you glossed over the box at the top on the left, which looked like your standard algorithm.
I didn't gloss over it. I got to it and thought, I don't know what's happening here.
Well, what's happening is another mistake, Caroline.
Okay.
So when you multiply 1 times 29, which you're supposed to do, you don't get 290, you get 29.
Oh, there it is. And then they've done the exact opposite on the top. In other words, they've done the 5 first and the 1 after.
Yes.
And they've
Yes.
still done so. Oh, right. I see it
No,
now. I can
so
see it now.
so often when children are taught a particular, well, when they're taught that algorithm, as a matter of fact, they don't know what they're doing.
Mm-hmm.
They just think, well, I've got to do something, and I've got to multiply the numbers underneath one by one with the numbers on the top, and I've got to put a 0 on the end of one of them. And they've done all that, except that they've done it all wrong and they've got the wrong answer.
Yeah.
So it is important, not that they can calculate quickly, because in these days calculators and computers do the work, but that they actually understand what they're doing. And clearly, whoever did that on the top left, well, it was I invented it, but whoever did it on the top left, and children really do make those sorts of mistakes,
They certainly do. Yeah.
is just using the algorithm in sort of in a way which is just all muddled because they don't understand it.
Yeah, they're doing the actual calculation correctly, as in the arithmetic, the 5 times 9 or whatever, the 5 times 29, but not getting the place value right. They don't actually understand the process, which is where the top right, the two-way table, is that what it's called, Toni?
Yes.
On the top right is so useful. If you could actually go through all of those methods, and as you can see, I didn't go through them all before we started thoroughly. I looked at some of them and not that one. I'm like, what? My brain went for a loop when I saw that. But doing it with the table on the top right really does make very clear what we call place value, which is
well, what you're doing there is instead of multiplying 51 by 29 in the way that's often taught in school, you're thinking it as not 51 but 50 plus 1, and not 29 but 20 plus 9, and then you do it in 4 separate little packages, and you multiply your 50 by 20, and all you've got to do is multiply 5 by 2, but understand that gives you 1,000, because it's 50 by 20, and then you've got to multiply 5 by 9, which gives you the 45, but what you're actually doing is multiplying 50 by 9. So on the top row, you've got 50 times 20 added to 50 times 9, and you've got 50 times 29.
Yeah.
But it was all about 51. So you've got to do 1 times 20, which is 20, and 1 times 9, which is 9. And then you've got 4 numbers to add together and you get your answer. So it actually breaks down the method into simple calculations. You've got to get the place value right, but what you're doing is only multiplying 1 digit by 1 digit at a time.
Yeah, so all you need to know is up to your 9 times table in order to do this. Although 10 times is useful because when you've got your 20 times 50, it helps you work out whether it's 100 or 1,000 if you do 20 times 50. One thing I would actually, we haven't actually spoken about this before, because what I was taught in school, and I know that some of my tutees are still doing it, and that is, you see 20 times 50, you know it's 10, and then they just go, and this is how I was taught, you just go 10, and there's 2 zeros, so you just add 2 zeros, so it must be 1,000, without actually thinking, okay, I've got 20 50s here or 50 20s here. How big is this number? What does it actually mean? And it is just an algorithm. It's still being taught as an algorithm, though I know that because of my tutees. So what can you say about that, Toni?
Well, I'm sad because you said you add 2 zeros. Well, of course, if you don't.
That's how I was taught, which is why I'm saying it.
Yes, that's the wrong thing to say, because you're not adding 0, because adding 0 doesn't change anything. What you're doing is writing 2 zeros on the end, and you're actually pushing the numbers to make them bigger into the thousands place and the hundreds place. So you've got your 5 times 2 equals 10, but you've got to multiply by 10 and then by 10 again. And you do that by pushing the numbers to the left into the next higher place and filling that gap with a 0.
Right. And so but basically what you're doing is the order of magnitude is increased by 10 for every 0 that you're multiplying. So the 20, the 0 in the 20 is 1, the 0 in the 50 is 1. So for each of those zeros, you're increasing the order of magnitude. So you've got to start with the 10, the 20 gives you another 10, so that's an order of magnitude 10 times more, and then the 50 is another 10 times more, making it 1,000. And it's a much bigger number. And it's not just adding zeros, which is it's still being done, Toni. So that's why I wanted to say it.
And a good teacher actually encourages children to use their own methods, even if they're not very efficient. But if they're going to get there in the end, and then to look at different methods and to pick on one that's really efficient, that gives the right answer. And for some calculations, these ones like you see there, where instead of 29 by 51, you do 30 51s and then subtract 151. Those sorts of things. If you've got good number sense and by using this sort of teaching method, the children will develop good number sense. They can do these sorts of calculations. Now, the next slide is, this is concentrating on one multiplication of a 3-digit number by a 2-digit number. And on the left, you see the algorithm that is often taught as this is the way you do it. But on the right, you see the same sort of two-way table, but now we've got hundreds, tens and units instead of just tens and units, 3 digits instead of 2. But what I wanted to say here is that what is important for children to learn is to understand calculations and to be able to estimate roughly the right answer, as Caroline was just saying. And that's a human activity. Now, doing quick, accurate calculations is for calculators and computers these days. Nobody has to do that once they've left school, because not really. I mean, yes, I suppose I'm wrong. If you're in a shop and you want to work out what your change is going to be, you need to do a subtraction. And often, if you're going to buy so many of a particular item, you multiply by it. You might do these things in your head, but it's often overemphasized in school that you've got to be drill in doing calculations. Well, it's fine if you've got time for it, and it's okay, but if you don't have an understanding and you can't use the mathematics you've learned because you didn't really understand it, or you get it wrong because you didn't understand it, it's pretty useless. So doing accurate calculations, a mathematician knows how to use his tools, and the tools are things like a calculator. It used to be a slide rule when I was young, but it's a calculator now. Or you're just using the computer.
I did actually do not one year. My O-level year, which is what was the GCSEs back in the day, I had to use a slide rule up until that point, and then I used a calculator that year. But I did actually, I'm old enough to have actually used a slide rule.
And you see there the link. Now, on the Aiming High website, you will find, this is just a starter, you will find a lot more about this activity. You'll find notes for teachers with solutions, and a suggested way of teaching. You might use it in teaching. There's a inclusion and home learning guide. There's a worksheets that you can duplicate, copy to give out to the learners. There's a lot about this and to help you use this on the Aiming High website.
And that's not an active link, but there are active links in the description. So please click on that. And within that, also in the link, there is a link to the Facebook page, where every single day there's a little starter, a little snippet like this screen that you can see, a little meme that just has a moment of thought, of calculation, something to get you to think, and to engage you in the mathematical process. And there's just So if you just want that little moment every day, it can be a starter for a lesson, or it could just be something you do after dinner, whatever you'd like to do. But it's there every day, and every day it's something different on the AIMSEC Facebook page. The link is in the description.
Now, after the break, we'll look at some misleading statistics and more mistakes and how to avoid being fooled.
Don't be made a fool of by statistics. Make sure you understand your statistics, because, oh my goodness, you've got a treat coming up after the break.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Well, have you heard the saying that there are lies, damned lies, and statistics?
Yes. And have you heard, okay, this is a statistics joke. You ready, Tony? 59% of all statistics have just been made up on them in the moment.
Well, the trouble with statistics is that they can really tell a lie. And it can be just a mistake, or it can be a deliberate lie. The person who produced these statistics wants you to believe something, well, fake news. Now,
And can I just add there, you've got a mistake, you've got deliberate lie, and you've got ignorance, which is a mistake. But you can have somebody who knows what they're doing but makes a mistake, or you can have the vast majority of people that are kind of reporters would come into this category. They're not statisticians. They don't really understand what they're saying, and that's the really worrying thing.
now we're in a time where we're all hearing about statistics. We see graphs being produced on the news about the spread of COVID and about how many cases and how many deaths and how quickly it's spreading. And people perhaps don't understand what's being put in on the screen in front of them. It's quite important to be able to understand statistics. So it wasn't taught much in school when I was a child, but it is always taught now. Probability goes with statistics, and the two subjects are taught in school now, right from primary school. And statistics involves collecting the data in the first place. Might be a questionnaire, or it could be doing an experiment, like your experiments that are being done with the new vaccines to see if they work well and if they have any harmful side effects. So these are experiments, and they're planned. They're very carefully planned. So the first step is the data. How does the data come about? Either, as I say, from a questionnaire or from an experiment. And if it's a questionnaire, the questions have got to be good questions that are easy to understand, and that the answers will give you a clear indication of whatever it is you're investigating.
And they've got to be unambiguous, so everybody answers the same question. And also, the numbers matter, don't they, Tony? How many people you ask?
Indeed. Well, that's the next step. That's actually the number of cases that you are considering, of trials, is the term that's used. How they should be selected randomly from the whole population. We're assuming that you can't test everybody, or you're actually only going to do this experiment on a few people, and you're going to assume that they're typical of the whole population. But it only makes any sort of sense to assume that if you've selected your cases, your people, randomly. Okay, so whether it's people to answer a questionnaire or whether it's people to be part of some sort of medical experiment, you need to select those people randomly. So mistakes or misrepresentation can arise if you don't select your cases randomly. If you select them in some sort of way that actually just takes us some section of the population and not a cross section of everybody. Now then, that's at the beginning. Then when you've got your data, how do you represent it? How do you show people these numbers? Because if you just show people some raw figures, then they're very difficult to appreciate what those figures mean. And very often the data is represented in a graph. Now, I've chosen one example here, and the heading is over 100 million people are now receiving federal welfare. And this was produced in 2011 in the United States, okay? And what you see there is a bar chart with these bars for different questions being asked, but being asked in 2009, 2010, and 2011. And you see how the height of the bar is increasing, but it seems to be quite a sharp increase. It seems to be quite a big increase from the first one in 2009 to the last one in 2011, in 2 years. That seems to be a really big increase if you just look at those red bars. But that is misleading, because actually you've increased from about 97 million to 107 million. And although it is quite a big increase, it isn't as big as that makes it look. And the effect that graph has on making you think there's bigger growth than actually is true is by not starting at zero on the axis on the left, the vertical axis, which gives you the number of people. By starting at 94,000 instead of starting at zero, having it's a choice of scale on the axis, really. If you choose that sort of scale, it exaggerates the change. And if you want to exaggerate the change, then you can easily produce a misleading graph, and most people will be fooled.
One of my favorite quotes is it's a small newspaper it's in a village, and it says, we had 100% increase in crime last year, from last year to this year. And it turns out there were burglaries specifically. It turns out there was one burglary the year before, and there were 2 burglaries the following year. So that's doubled the crime rate of burglaries, but it sounds as though it's a horrendous problem because it's using 100% increase. So the size, you need to know that your data is coming from a reputable source, and also that it's not being used by a newspaper editor or a news producer to sensationalize a problem.
Well, it's so easy to get the representation of the data, to report the statistics in a misleading way, and often the person doing it is entirely innocent. It's because they're doing their best, but they didn't learn enough mathematics at school, learn enough about statistics at school.
The thing is that the job, it's important to be aware. It's kind of a life skill. It's important to be aware that news outlets are there to sell the paper, to get eyeballs on their news, to sell whether it's online or wherever it is. And they'll go, oh, if we put it this way, then it sounds more dramatic. We'll get more people looking. And without meaning to do harm, they have to look at their views. They have to look at how many viewers they have, how many papers they sell, whatever it is. So be aware of where you're getting the information from. And this is one of the many reasons why you want to, why should I do maths? Why am I doing this? I'll never use it again. Well, statistics is one of those things that if you don't understand the statistics, you could be hoodwinked throughout your whole life.
It could hurt you in the pocket too, because nowadays we are being subjected to so much advertising. It's not funny. And we are being asked to fill in, to rate whatever we've just bought or we've just used or some service or other and give it so many stars. Now, the way those ratings and the consumer surveys are reported are often deliberately misleading. And why? Because the advertisers want you to buy it, whatever it is they're trying to sell you. And it's particularly harmful when it comes to political electioneering, propaganda. And you may be sure that you'll be fed a lot of fake news and it'll be made to look quite convincing. It'll be wrapped up in some sort of way to tell you the story you want to hear. And often it is completely fake. And using statistics is powerful because people, if they don't really understand the statistics, they think they do, they're going to be fooled. And that's the world we live in, I'm afraid. So learn as much, we want the children in school to learn as much as they can about about collecting the data, about representing the statistics, about doing this in such a way as it's actually accurate. And when they see somebody else producing statistics and telling them a story based on the statistics, they can be critical. They can actually use their minds to be critical and not to be hoodwinked. Okay.
Well, the better you are at maths, the less likely better you are at statistics, the less likely you are to be hoodwinked. Hey, that's a great life skill.
We could spend not just 1 hour, but many hours on mistakes in statistics. Now, here's a mistake in geometry, and this is a classic one that if you teach maths, you'll know this one. So you've got to draw a triangle ABC. You're given an angle and the lengths of 2 edges. AB is 6 centimeters and BC is 5 centimeters. There you go. There it is. That fits the bill, doesn't it?
I'm just going to be a parent here, Toni. So you might not have seen a question like this for many, many years, and some of you might not have even done a GCSE in maths. So I'm going to say, so the triangle has 3 vertices or 3 points, A, B, and C. And when it talks about the angle BAC, it is the A's in the middle, so it's the angle of A. So that's the way that we describe to make clear what angle we're talking about. And then the length of the 2 edges are the edges that go from B to A and B to C. I'm just making sure we're all on the same page, Toni. Right, go ahead.
Okay, well, that's as far as it goes. It's a solution.
Looks right to me. You've got 6, you've got 5. It's following. It's doing what it says.
It's not all there is to say, because there are 2 possible solutions, and here they are. You see, there you see the triangle that we've already drawn, with the edges that are of length 6 and 5 centimeters, and you see the angle of 50 degrees. But the other triangle, ABC1, also has AB is 6 centimeters, BC2 is 5 centimeters, and the angle at A is still 50. So what applies to triangle ABC1 also applies to triangle ABC2. So you've got 2 solutions there.
So this is for people that, parents of people, for learners that are a bit older. If you're around the age of GCSE, I may have known this when I did my GCSE, I don't remember, but apparently, I learned this today again, if you see a question like draw the triangle ABC with that criteria, that implies that you should draw all the solutions, not just one of them.
It isn't just about geometry. Whenever you're asked to solve a problem, okay, if there are 10 solutions and you only give one, you've only got 1 mark out of 10. If there are 2 solutions and you only find 1, then you're only going to get 1 mark out of 2. It's solving problems is not about finding only one solution, it's finding all the solutions and finding the right one. Well, sorry, not the right one, but if there is a best one, then finding that. But you won't know unless you found them all.
You've just found another life skill there, Toni. Why should we bother with staying engaged in maths? It's so that when we go through life, we all have the we've practiced the skill of, if we have a problem, see if you can find all the possible solutions, and then you can make a better decision about which one to choose.
Okay, now after the break, we'll talk about how the maths we learn in school is used in solving problems in the real world.
Well, we've already found a few of those, haven't we? So this is going to be good. Right, and see you after the break.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Now, there's no point in learning maths at school. It's a complete waste of time unless you learn to use and apply the maths, unless you can actually use your maths to solve problems. Applying.
I'm looking at this, Toni. I'm looking at this slideshow, and might not be the only one. And I'm going, what's this got to do with maths? And how on earth am I supposed to understand this?
Well, we've just been talking about statistics and COVID, and the words have been used quite often by by people on the radio and television, that what the epidemiologists, what the scientists are doing is building mathematical models. And that is the way mathematicians solve problems. And in many, many spheres around, in many jobs, almost everywhere, you'll find there's some maths being used. And, well, we could spend a whole year, every day, hours and hours. We could be talking about using and applying maths and problem solving, mathematical modeling. It's a big subject. So we've just got 5 minutes now. Now, I put a very complicated diagram on here. I don't expect anybody to fully understand this because it would take a whole course in mathematical modeling to, to appreciate all the subtleties of what's in the diagram. But it's there, I'll say a little bit more about it. When we've got a problem to solve in a real context, so we're actually using our mathematics for some good purpose, we're either presented with that problem, which somebody's written down, or it might be that we have a situation which We're trying to look around and understand, like the spread of COVID, for example, and then we have to build a mathematical model that exactly fits the specifications. In either case, mistakes can arise. We're talking about making mistakes, spotting mistakes. And spotting those mistakes helps you to get it right, to actually solve the problem in a way that's leading to a good solution that will be useful. If it's a written problem, then reading comprehension is really important, because if you don't understand what you read, there's misinterpretation of this written description, then mistakes will arise. So,
and how many of us have time and time again during our school career not read the question properly and got the answer wrong, not because we did something wrong, but because we didn't read the question, and therefore it's just comprehension of the question. And it's attention to detail too, because the question is probably complete, but you're not noticing the detail, the nuances in the question to make sure you're doing it right.
Yes, and building the mathematical model can be, you're in a situation, you know about the situation, and you have to try to use mathematics to find a solution. And you may need to find out more facts in order to be able to build your mathematical model. Your mathematical model may only be sort of moderately good. I mean, weather forecasting is a good example. Forecasting the weather is all uses mathematical modeling. It uses air pressure and wind, temperature readings, and knowledge about winds and so on, and puts them all into some big mathematical model and comes up with a forecast that tomorrow is going to be sunny. So you plan something nice to do on a sunny day and wake up in the morning, and what do you find? It's raining.
Yep, raining, windy, and the jolly weatherman. What on earth were they doing? Why did they give me the wrong information?
Well, they're doing their best. I mean, and sometimes, more often than not, they get it approximately right. But weather forecasting is all based on modeling, and don't let it make you just say, oh, well, that's all rubbish. Mathematical modeling is always wrong. It is because it's so complicated and it changes so quickly. They do actually, the modelers do, they always do forecast things like typhoons and tsunamis and big changes in weather. It's the subtle difference between well, it might not seem quite such a small difference between a rainy day and a sunny day, but anyway, it's not typical of mathematical modeling in general.
I have a question, Toni. Is, for example, the airways, so when there are airplanes in the air, because you know what all the timetables are of all the airlines, is that a mathematical model? So working out where every plane's going to be and how to interact with them?
Oh, absolutely, yes. And the people in air traffic control are using mathematical modeling to control the flight paths and make sure the airplanes don't crash into each other when they're coming near an airport, and in many other ways. In fact, these days we have driverless cars. We have for a long time, the pilots have been able to sit back and let the automatic pilot actually fly the aeroplane. And this is all computers, and they're all working from mathematical models. And the mathematical model is put into the computer in the form of a code or a program. It should be called computer programming. It's now often called coding. And they are models. They're mathematical models, yes.
And they're used in insurance as well. They're used in many industries where they specifically hire mathematicians to do a job that isn't strictly mathematics, but having that knowledge is having a mathematician doing the work is very useful, because that person knows how to analyze and has the ability to spot all the possibilities and make great decisions on which ones to choose based on experience and
the mathematics.
and the mathematics. Yeah, let's not ignore the mathematics there.
You mentioned insurance. Interestingly enough, my father wanted me to be an actuary because he knew I liked mathematics, and I didn't go that way, but I did have some experience when I was very young working in an actuary's office. Now, the block diagram on the right there, it shows 8 different cubes built into a block, and each one of those cubes shows a particular type of mathematical model. And there's a little message there to focus on one type of mathematical model at a time. Now, on the top layer, all the models, the types of models, are what's called stochastic. Now, that means based on probability. And Caroline just mentioned insurance. We've just been talking about predicting the weather, and we've also been talking about the spread of epidemics like COVID. And they're all based on probability. And that's why there's a built-in uncertainty. And people who are statisticians and really understand probability can sort of get on top of it and give you a really good prediction. And what's more, they know the degree of certainty or uncertainty. They know the degree of accuracy or inaccuracy in the model. So there's a lot more to it than what you'd learn in school, but we haven't got time to go into it all.
Well, what you learn in school does help you understand at least what is broadcast to the general public. This is absolutely fascinating, Toni, and thank you for giving that simple explanation, one that I can understand. If I can understand it, then that's simple enough. A bear of a simple brain. I'm not going to say little brain. A bear of a simple brain. It has to be simple for me to understand it, and that's not a bad thing. It doesn't. If you're like that, doesn't mean that. As a parent, especially if you're befuddled by the maths that your children do, it's just a matter of persevering. And on that note, everything we've spoken about here is in the resource that you can see, the activities that you can see on the Aiming High. It's going on the ticker tape below, and there is a home learning and inclusion guide, which means that there are instructions for parents on going through these activities that we've just been talking about, and notes for parents, questions for parents, and not just the parents, but older learners, carers, whoever is guiding a younger learner. And there's also very challenging questions for people that are at school leaving age. So it's inclusion, as in it goes from age 4 to age 18, wherever you are, or if you're just doing recreational maths, they're lovely activities. I love doing them. So that is all the time we've got, Toni. Thank you so much for your amazing resource again. And we'll see you next week, same time, 5 o'clock London time, Happy Maths Hour. Over to you, Toni.
We'll see you next week, yes. And we could have talked all day about one of those items about statistics, for example, about mathematical modelling. Maybe we'll come back to these topics another time.
That would be great. Thank you, Toni. See you next week.
Goodbye, everyone.